Welcome everybody to this breakout session on social and psychological implications of artificial intelligence. My name is Stefano Puntoni and I'm a professor of marketing at the Rotterdam School of Management, Erasmus University. Before I start with the content of my talk, I would like to introduce you to our new lab at the Erasmus Center for Data Analytics. It's called the Psychology of AI Lab, and we study the human side of data science. We have two associate professors affiliated to the lab, beyond, of course, in addition to myself, Anne Kless and Gabriele Paolacci. We have two PhD students, Gizem Yalcem and Almira Bilova. And this summer, I'm delighted to have two additional assistant professors joining to work in this area, Romain Cadario and Johannes Borgerhausen. So what we do in the lab, we run mostly experiments or behavioral research more generally to understand, as I said, this human side of data science. And most of the attention goes to understanding consumer acceptance and societal acceptance of AI and automation more generally. We do that a lot of it in the consumer domain. Obviously, we are marketing researchers, but also we look at it in a broader sense. We also look, for example, medical AI and adoption of various different technologies. In addition to that, we have work on beliefs about technological replacement of human labor, how people feel about machines taking over human labor, and also about trying to blend management with cognitive science and understand how analysts make sense of data. We publish our work in the top academic journals in the Journal of Science or Marketing, but we also try to disseminate our work through outlets with broad reach, such as the Harvard Business Review. This is basically a little introduction to my work and our team. And what I'd like to do now is to introduce you to a framework for understanding how organizations should think about the division of labor between humans and technology and machines. And to do that, I'd like to frame the discussion on the broad topic of how the societal debate around AI is evolving. And we hear a lot of voices, a lot of discussions around the topic of AI and society. This great summit today is a perfect example of that. And if you try to understand what kind of discussions are evolving around AI, I think it's useful to think about two broad camps. And the first one, I call it technological solutionism. And it's a type of thinking that originates from the tech sector and here the Silicon Valley type of mindset. And here technology is seen as basically a way to solve problems, and that provided you have smart enough engineers and programmers that tackling an issue, they'll be able to provide solutions that basically can address almost any problem in society. This kind of thinking is often very let's say, technocentric and somewhat utopian, where you see technology as a solution to almost every human problem. On the completely opposite spectrum, you see also a lot of voices that have a very different tone. They are much more worried about the deployment of AI in society, even coming to the point of raising fear about the dystopian future where AI is preventing societal outcomes that we want, or where it might even lead to an existential threat to humankind. You have heard several people arguing about the danger of an unrestricted general artificial intelligence, although this is very far away in the future if we'll ever get there. And here I have a picture from the moment of the Luddites, the people at the beginning of the Industrial Revolution trying to smash machines, taking away jobs, just to indicate some of the dangers that come with that fearful stance, which might be also preventing the adoption of technology. But at the same time, also highlighting some of the genuine concerns around AI. And one of them that is suggested by this historical reference is the one of AI's role in replacing human labor, and how that might put pressure on society and particular social groups within society. Trying to study that effect and how it relates to the AI revolution now, I think it is useful to investigate a little deeper this notion of replacing versus enhancing human skills and human labor. If you're interested in this topic, by the way, I would advise you to read this book by Carl Frey, an economist at Oxford, called The Technology Trap, and it's a history of a technology book, you can say, where he examines how technology over time, different technologies over time, have enhanced or replaced human labor with different outcomes for, let's say, inequality and well-being of society. Now, generally, economists emphasize the fact that the technology is good. Of course, it's good. It leads to better ways of solve problems, more efficient ways of solving problems, and eventually more wealth for everybody. But even those technologies that had very strong complementary effects on human skills and they helped create many better jobs, take electricity or inventions like that, or the steam engine, nevertheless had powerful conjunctural effects. There would be periods where people had to be displaced for existing occupations and roles and until they can find new occupation and new roles. And I believe that we are going through a new conjunctural moment where many people will have to reassess their role in organizations with potentially quite stressful consequences. So it is important we understand those conjunctural moments. With that in mind, I try to contribute something a little bit more practical to try to understand how we can think about this division of labor. And if you read about AI and work in the popular press, there are some domains where people say, well, humans are going to be in charge here, where machines will maybe do some, but they will not take over. And one of them is creative work, that only humans can have this pair of insights, this creativity, and therefore we should nurture human creativity and we should basically leave machines to do something else. Another idea that you hear a lot about is the idea that emotion work is for humans, that machines can maybe think better than humans, but they don't feel. So people, for example, have predicted the emergence of a feeling economy to complement the thinking economy. And while the feeling economy will be run by humans, the thinking economy will be run by machines. Okay, so these are some ideas that are out there that you probably read about in the last 2, 3, 5 years. And I like to go a little deeper in each of these and make some examples that perhaps seems to go against that commonplace wisdom around these topics. So for example, here I have 3 pictures. The first one is a new fantastic concert hall in Hamburg designed by an algorithm. The second is an icon for an app released by Brian Eno, the famous musician and producer, that is basically an AI algorithm that can produce endless streaming of music in Brian Eno's ambient style. And the third one is a screenshot of Smart Compose, a Google app for to assist people in writing. Now, clearly, algorithm can do creative work, like these examples show. The question is what kind and how, and what are humans going to do? Or take emotion work. Okay, yes, it's true, machines don't feel, but that doesn't mean that emotions cannot do emotional work. So machines are excellent nowadays at recognizing emotional expression. And provided you feed the algorithm with sufficient amount of data about how those emotions relate to particular market outcomes or behaviors, you might be able to train an algorithm to do a lot of emotional work. And that's already happening in many industries, from advertising, services like call centers, and many other situations. So maybe actually machines are going to help also in these domains, which were supposed to be the ones where humans had exclusive let's say, roles to play. Now, the question then becomes, what's going to be next? If already machines today are able to start doing this task that we believe to be more human, like creativity and emotions, then what is going to be left for us? Is there going to be anything left? So if we were doing manual labor and then now we moved to physical labor, because machines took over that manual labor, if machines now are taking this cognitive labor, what kind of labor is going to be for us out there to do? And that underpins this concerns and underpins a lot of these fears that you hear about displacement and AI in society. Now, a lot of those voices are a bit gloomy, and I think there's maybe more attention to be gotten by being gloomy than being cheerful. But I would like to be cheerful and have a more positive message. This might look like a sunset, but actually, I think it's a dawn here in Rotterdam, and I like to exemplify that as the potential that AI has to not just replace humans, but to help humans flourish. That's what I hope we can have AI do. To introduce our framework, I like to maybe start very far from a place that seems almost odd to bring in the context of artificial intelligence, and that is art. Before I start, I'd like to acknowledge that this work is joint work with my long-standing collaborator, Bart de Lange from ESADE, a business school in Barcelona, Spain. And together we've been working for 2 years to develop a framework for effective decision-making. We have published a lot of academic work, but we've also tried to reach out more to a managerial audience and try to think about more from also a practical standpoint. And what we did was to create a new 3-day executive program called the Rules for Effective Decision Making, which was basically the excuse for us to sit together and think of this framework for effective decision making. By the way, allow me a little pitch here. The next round of this program will run at the beginning of September. You can check and read more about that on the rsm.nl website. Okay, so some of the ideas I'm going to present right now, for those of you who saw me present at the last RSM Leadership Summit, we've been developed this over a year or two, and we've used the Corona lockdown to make a lot of progress. So I'm going to share a lot of new ideas, but the beginning is something that may be familiar to some of you if you have taken my course, if you have listened to me at the Leadership Summit. Now, let me start with trying to learn a lesson from art. If you try to, and this is the place I was telling you, they're very far away and a little bit surprising, but bear with me. I think there's a very interesting insight to gain. If you look at the history of Western art from the Middle Ages up to the 1850s or so, it's a gradual, it's a story, a broad stroke narrative of Western art. It's really a gradual and continuous improvement in techniques and realism and quality of representation. Artists over time became ever better at representing reality in an accurate and lifelike way. So starting with the invention of linear perspective in Florence in the 1400s, this is a painting by a painter called Perugino that stands in the Sistine Chapel in Rome. And here you can see the depth, the realism that was completely missing in earlier medieval painting. Now, Renaissance artists developed these techniques and kept them improving throughout the 1500s. When then you see in more Northern Europe, in the Flanders, in the Flemish painters and in the Golden Age Dutch painting, this atmospheric perspective, the light, the reflection, the perfection of the indoor spaces. If you move yet again another 100 years later, here was a period of the Grand Tour of Europe, where nobles and rich aristocrats would tour different cities of Europe and want to bring back some mementos, some souvenir. This is basically art, a little bit like our postcards, where people would then try to create memories or keep memories of those cities that they saw. This is a painting by Canaletto, famous painter of the 1700s. And here you see expansive outdoor vistas, very, very detailed, perfect, real-like, almost like you were there. Around 1790, European art was dominated by a movement called then neoclassicism, which dominated European art until up to about 1830, 1840. And here again, the idea was to create representations that were so accurate that would even beat the classical art of the Greeks and the Romans. If you look at this sofa by Antonio Canova, a famous sculptor, you can see it's almost like it's almost soft. You can that marble you can lie on. And this is basically the history of Western art for 400 years, 500 years. And then 1889, you get this. This is the famous Starry Night painting by Vincent van Gogh. And at the same time that Van Gogh was painting this, you had Degas, Renoir, Toulouse-Lautrec, Monet, and many others who were painting dances and sunsets and cathedrals and bars and so forth. This art is completely different from the art that I showed you before. Completely different. Maybe even a child could paint like Van Gogh, but his goal was not to create perfect representations of the sky the way he was looking at it when he was painting it. He was trying to do something different. He was trying to explain a perspective on the world, to interpret what he saw, to give you a new way of looking at the sky with these swirls, with these colors. How could this happen? How could we go after 500 years of gradual transition to this within just a matter of a generation? This is an important question for art historians, and a number of factors played a role here, but there is consensus that one machine was crucial to enabling this transition. and to open up the incredible variety and explosion of creativity that came with the contemporary art. And that is photography. This is the first photo that is known of Paris and the first known photos of a human being. You can see that guy there in the corner of the pavement. It was taken by Louis Daguerre in 1838. With the invention of the photo camera, a dilemma was raised to artists. Now the machine could represent reality better than artists could ever do, faster and more accurate. And now what do? Do we stop painting because a machine is better than us? No, we don't stop painting, but we need to change the way we paint. And we need to move from a focus on representation to a focus on interpretation or impression, like this movement called the famous Impressionist, right? And so what I want to highlight here is that just like the history of art gave us this glimpse of what machines can do to humans, what they can do to human potential, by liberating humans from the need to worry about representation and enable them to explore this idea of interpretation. I think this is a profound distinction that is very relevant today in the era of artificial intelligence. So let me sketch that distinction a little bit more. So Bart and I are at the boundary between data science, business, and cognitive science, and we try to develop a very concise and we think useful framework for companies to think about the role of machines in today's society. And we distinguish between representation and interpretation. Representation is basically made of two building blocks, two cognitive activities. The first one is recording, collecting and storing information, basically what psychologists would call perception and memory. And the second one is matching, which is assessing the similarity between different pieces of information, what you can call pattern detection. Instead, interpretation is also made by two blocks, but one is called slicing, which is a decomposition and recomposition, decomposing wholes into parts and recombining these parts to create new wholes, what you can call categorization and the property of compositionality. And finally, explaining, which is trying to understand how different elements of a system relate to each other, what psychologists call causal reasoning. These two building blocks of intelligence are crucial because they enable us to have a consistent and comprehensive view of the world, that is representation, and they enable us to have a flexible and insightful view of the world, that is interpretation. Okay. Just to give you an example of how this can be a framework can be applied to business, let me make an example from marketing. Just before I introduce that, this is a summary figure of the framework. We have this base, this building blocks, so recording and matching. You can now represent the world. The machine have an edge on this. They can record sense environment better than we can. They can do matching much faster and more accurate, consistent way that we can. At the center, there is slicing. It's a bit to understand how to look at things differently, recomposing, decomposing it, and understand what are the fundamental elements of a system. That is slicing, and lie at the center because slicing powers everything else. And on the top, we placed explaining, interpretation in the sense of causal reasoning. What causes what? What happens if you change something? This is, again, together with slicing, where humans have an edge. So now you see this idea of division of labor. You shouldn't assign functions to machines. Machines can do, say, cannot do emotions, or cannot do creativity. No, you should think about cognitive building blocks and assign those to humans and machines. The domain of machine is representation. The domain of humans is interpretation. Here's the example from marketing. Take customer relationship management. You start with slicing customers into demographics, or any other way of describing customers. Then you record these variables through sensors to create a database. And then basically you are running some statistical techniques like a regression to try to link those customer characteristics to relevant business outcomes that you care about, whatever those are. And finally, once you learn how these relate to each other, you have to create some kind of ideas about how customer behavior is driven so that you can design initiatives to improve the business outcomes that you care about. So represented, then you have slicing, recording, then matching and explaining, which in turn require human design, especially at the beginning and the end of the process, and then machines to do a lot of recording and very fast and consistent matching. Let me make another quick example, and that is going back to the creative work. So if you think about the versus society, we have two archetypes of creating discovery. The first one is this idea of discovery as an epiphany. Imagine Newton getting an apple on his head, or Pythagoras, sitting in the bath and screaming Eureka. But there is also another way of thinking about creative discovery, exemplified by quotes like Edison's, "I have not failed, I've just found 10,000 ways that won't work," or Louis Pasteur saying, "Chance favors the prepared mind." This is a different view of creative discovery. It's a view where we see discovery as a serendipity, as a moment of discovery caused by, you recognize something out there that is valuable. Take, for example, Pfizer developing Viagra, the first erectile dysfunction tablet, in an attempt to develop a heart medicine for angina. So discovery is serendipity. And social psychology research confirms that there are really two different ways to be creative. What this model, the dual pathway to creativity model, says by Neistat and colleagues, you can have a cognitive flexibility pathway or the cognitive persistence pathway, where the first one is about an association process. And more holistic thinking, more flexible thinking can enable better digital associations. This is more like the idea of epiphany, the apple on the head. The light bulb goes on. The famous cliche. The second one is that creativity is a stochastic process of search. You search a space and you find solutions that are good. So you need to search a lot. And you search a lot and you can get a more creative output. Cognitive persistence. So creativity is persistence. Now you can maybe intuit already the link between creativity and our framework on representation and interpretation. Going back to the proverbial box in creativity, cognitive flexibility is really the creativity outside the box, thinking about something different. Creativity as interpretation, making links, slicing and interpreting things in a new and interesting way. The second one is thinking inside the box, is creativity as representation. You search a space of possible solutions and see whether something is good or not, cognitive persistence. So it's not true that machines cannot do creative work. Machines can, but they can only do the cognitive persistence pathway to creativity, the thinking inside the box. Creativity is representation. Provided you can frame a creative endeavor as representation, you can use machines for that. Whereas if you frame a problem as more of an interpretation problem, then machines can't help you. So you need to go one level beyond. And the same story, I won't be able to do it for the interest of time, but the same story you can do about emotion. If you can describe emotion work as representation, then machines can help you. These are some examples from machines doing creative work. On the left, you see some artwork done by an AI algorithm. And it's done by, you train a machine learning algorithm to look at a lot of paintings and then create something new. And this is art that you can display in a hotel lobby or an office, but it's derivative art. It's art within the box. So it can look good and pleasant, but it will never be groundbreaking. Because art in this figurative sense fits better in creativity's interpretation pathway. But look at the second one. There are, at the latest count, over 200 different startups trying to use artificial intelligence in drug discovery. Why? Because a lot of scientific discovery can be framed as a representational problem, as a search problem. And if you can do that, then you can use AI to facilitate that process of discovery. So creative work, yes, machine can do it, but only part of it. So you need to understand which part of your creative endeavor in your organizations can be described as interpretation and representation, and then give it to humans and machines accordingly. This is basically my to wrap up this discussion, and we're going to have a few minutes for questions. I just want to end by highlighting again that I think AI is incredibly exciting. We need to understand how AI and humans can work together so that organizations can optimize the collective intelligence of carbon and silicon. And yes, machines have superhuman abilities, but let's not forget that humans still have super machine abilities as well. That was the end of my talk. I would like to, before I open for Q&As, just a little reminder, if you are paying attention, why don't you go on LinkedIn and send me an invite? I'd love to connect. Okay, with that one, I'd like to thank you with attention and just open it up for a short Q&A.
So thank you, Mr. Puntoni, for your time, and thank you for this amazing talk. Everybody can ask their questions in the right bottom corner at Ask a Question on the website. In the meantime, I already have some questions for you. So the first question that someone sent was, so do you think AI will impact the way we do art in the future? And if so, how will it?
I think art will not be the domain really of machines because of what I just explained. But I do think that the machines can be incredibly helpful to help artists become even more creative. Maybe machines can be a tool for creative discovery in the arts. And I think if you look at the arts from the last 50, 60 years, there is plenty of examples like that. I showed you already, I made the example of the photo camera, but I think film and many other technologies have been used by artists to create something new, to give a new perspective of the world, to do interpretation. And I expect that to continue. With also AI and other tools. But I don't expect that, AI will replace human artists. That is a domain that is pretty safe, I think.
Okay, thank you for this answer. I have another one. So someone says, "Dear Prof. Stefano, can machines ever be called creative from a Jungian perspective?"
From a Jungian perspective, okay. Now you're making a very difficult question. I cannot answer that question. I have no idea what Jung had to say about creativity. I'm sorry.
Okay. So another question someone asked is, so will BI? So as you said, like the machines are the thinking, but in the future, do you think AI will be able to influence the emotional economy as well?
Yeah, that's my point. Yeah, it will, of course. And I think it's already doing it. I think what you do observe is the ability of algorithm to assist a lot of potentially emotional work, like, for example, in a call center, monitoring, how the workers are feeling, but also helping feed operators with appropriate responses from that can facilitate increased efficiency and effectiveness. I know, for example, KLM is already doing that, using algorithms to help customer reps that are going to reply to your request by making their job faster and simpler. They don't necessarily do the emotion work, but what they do is that they take care of a lot of things that enable this customer service to be better. So if you mean by emotion economy, service, basically, service and care of some sort, yeah, definitely they can do it. But they can do it by taking on the representational part and leaving the interpretational part. For example, they might recognize that a customer is feeling something, but it doesn't necessarily understand why or what to do about it. And so what that can be done then is either to scale up that system and maybe provide some solutions to that, or feed that information to an operator who can take it, like in the case of KLM I was mentioning.
Okay, thank you for this. Someone else asked, how about robots looking like humans? How would that affect the identity of a consumer?
Yeah, I mean, now this is also a very difficult and a philosophical question. I think what you see is there's a lot of interest in the topic of robotic anthropomorphism, making machines look like humans, both in terms of the voice, like your Siri on your iPhone, or chatbots on a website, and of course also humanoid robots in many situations. And there's a lot of effects being documented in the last 2, 3, 5 years showing that anthropomorphism can play a role in increasing acceptance of algorithm decision makers. And so I think you will continue seeing more work. But I also think that there is a danger in anthropomorphism. So if you take, for example, this idea of a virtual personal assistants like your Cortana, your Siri, your Alexa, they all have a female voice. And there have been a lot of discussion showing, suggesting very rightly that there is a concern with the idea of having female servants, and that people get used to speak to them like they are robots because they are machines. And I think we need to be very cautious about the impact of this anthropomorphic use on society. And I think actually maybe in some situation we should be focusing less on anthropomorphism and make machines be less like human in that regard.
Okay. Yeah, that's a very good answer and very interesting. And maybe a last question. Do you think that AI doing creative work can be a threat to the sense of humanness, of the humanness?
Yeah, so this is related also to the previous question, what is humanness? And I think, yeah, there's a lot of people that have been writing about the notion of cyborgs, where basically it's not going to be us or the machine. In some way, we are going to merge with the machines, right? And of course, this thing is outside our body, right? The smartphone, but it's already like it is an extension of our body, right? In only 10 years, that device has become so crucial to us in an everyday life. We use it for hours on end. And it's doing a lot to expand our cognitive abilities, our ability to reach out beyond the here and now. And so we are going to see, I think, an increasing deployment of technology for the service of humankind, but that has to be managed very carefully. Many people have a tracker that tracks where they go. There are issues of privacy, there are issues of autonomy. There are many interesting questions around that. And in our Psychology of AI lab, we are trying to work towards understanding those problems so we can offer policymakers and companies useful insight into how to best deploy this kind of autonomous technology.
Yeah, so yeah, Mr. Puntoni, I want to thank you so much for answering all these questions and bringing this lecture for all the students. And thank you for your time.
It's a pleasure to be here. Thank you for assisting, and thank you all for watching.